Hi, everyone. So when they asked me to come up and speak about animation in apps, they failed to mention that I'd be on after Brenda Chapman. And in fact, I even wrote this talk before I knew she was speaking, and you'll see why this is funny in a minute. Today, I'm going to talk to you about animation and user interface design. This is a huge topic, and I could wax poetically on about it forever. But I'm going to take us down a slightly less beaten path, starting with a little bit of history. We all know animation as software isn't new. It's been around since the invention of the user interface itself. In fact, it's Apple's HyperCard that brought us such hits as the animated cursor, including the now all too familiar beach ball, which could be advanced by repeated HyperTalk invocations of set cursor to busy, or so some old guys told me. And that's the most technical thing I'm going to say today, but I will make my sample code available at the end. So over time, advances in programming languages and exponential increases in computing power have removed most of the barriers that used to exist. And now we can extend animation beyond the bare minimum to nearly anything imaginable. But with great power comes great responsibility. And it kills me that I had to set that in Arial to be precise. So fast forward from that to January 2007 and the introduction of the iPhone. Now that completely reinvented the concept of a smartphone, as we know. And there were three things during that talk that stood out to me during the announcement. The iPhone used a brand new input method, our fingers, which is also the only input method, had this large, vivid display which took up the whole front of the device, and had a buttery smooth interface with responsive animations all over the place. Slide to unlock, sliding page transitions, inertial scrolling, cover flow, these are all directly manipulated by our fingers. So suddenly the bar was raised much higher for animation in UI. Users have since developed an appetite for it. They expect to be able to manipulate things and see them react convincingly. And now 6 years later, this has trickled down to other smartphones and come back full circle to the desktop. So Apple paved the way with direct manipulation and this responsive animation in UI with the iPhone, and then followed it up with the iPad. And before that, we already had animation on the desktop going back a couple of decades, as I showed you. But we all know that animation has been around much longer than computers. And if we keep tracing its history far enough back, we come across the masters. Walt Disney Animation Studios created a number of now standard innovations in animation going back to the 20s. They started with shorts and then created full-length features, all the while defining the standards as they created them and continued advancing the art until today. So these are truly the pioneers of animation. In 1981, Ollie Johnson and Frank Thomas, two of Disney's most influential animators, published this book. It's called Disney Animation, The Illusion of Life. It's this gorgeous hardcover book. It's 576 pages heavy. It's based on the work of the leading Disney animators from the 1930s and on, and in their efforts to produce more realistic animations. It's got fantastic illustrations and examples, and most animators consider it their Bible. And so there's a chapter in this book called The 12 Basic Principles of Animation. And these are devised as a set of rules that define a realistic impression of emotion within the laws of physics. So I'm going to walk you through them and show you how they can be and have been applied to modern user interfaces. These principles aren't mutually exclusive, and they're frequently seen together. But by examining the individual nuances of each one, we can understand the role that they play. So I'll briefly touch on a principle with an abstract example, a very abstract example, and then show you an example in an iOS app. Through the magic of modern technology, I've managed to capture these at 60 frames a second, and I've slowed them down by half, so you can more clearly see the different parts of the animation. And they'll be looping as I talk. The first one is squash and stretch. So squash and stretch conveys how objects can transform under speed and collision. So it gives a sense of weight and flexibility to an object. If you think of a ball sailing through the air, it stretches out as it gains speed, and then compresses when it collides with something. If you want to give people an illusion of solid surfaces and planes, you simply reduce the amount of flexibility and transformation in your object to convey rigidity. So the absence of squash or stretch speaks as much as its inclusion. It's also important to remember that an object's volume doesn't change when squashed or stretched. In 2 dimensions, like this example, the ball collides with the floor vertically, which reduces its height, but the volume is maintained by increasing the horizontal width by the same amount. It sounds trivial, but it helps maintain the illusion. So a good example of this is Apple's adoption of pull to refresh. As you pull down past the top of the table view, in Mail, a gray circle comes into view, and it's pinned to the bottom of the nav bar and also to the top of the table. And as you pull down, we see it stretching. There we go. Until you pull down far enough that it snaps back, triggering a refresh. So this gives the user an indication that their action is causing a reaction. It's also very simple in that it's just a refresh arrow contained inside of a circle, and when it stretches in response to the pull. And there's no unnecessary visual fluff. It also includes the displacement of volume. If you look closely, the diameter of the circle gets smaller as that bottom point gets stretched out downwards. So this ties in nicely with the inertial scrolling of the table view too, because it's almost as though the elastic were pulling the table view back when you don't pull it far enough to make it pop and refresh. So if you pull it down without triggering a refresh and let go, it's almost as though that's what's pulling it back into place. Anticipation. Anticipation helps prepare users for something that's about to happen instead of doing something they're completely unprepared for. It draws the user's attention to the start of something bigger. So think of this as like a golfer bringing his club back before swinging at the ball. We can anticipate that that's what he's going to do. And this principle is all too relevant when we're talking about gestures too, because they generally have to be discovered by users. And you can use anticipation to hint at their existence of a gesture or guide users through it. So in this example, we're looking at the transition to and from the first page of apps on the springboard to the search screen. So as the transition to the search screen completes, the keyboard slides up so users can get to searching right away. They can start typing and see results. What I like about this screen and how it relates to anticipation is that as soon as you start to swipe back out of search, the keyboard slides down off the screen in anticipation. This exposes the pagination controls and the anchored apps at the bottom of the view, and it prepares the user for the transition back to the first page of apps on the springboard. So all it takes too is a small movement as you start the gesture towards the home screen. The keyboard will slide down, but then if you abandon it before getting too far, the keyboard pops right back up. Staging. Staging is the presentation of an idea so that it's completely and unmistakably clear. Now, this has its origins in theater, where actors still have to find ways to make the audience understand what's going on within the confines of the physical stage, the venue, the lighting, the way they stand, and their positions relative to each other, and so on. So I like to start about thinking what I need to communicate to a user, and then move on to how I'll accomplish this within the constraints of my canvas. Because while a touchscreen is a closer connection between users and an app, they're still just interacting with a 4-inch piece of glass and aluminum in their hands. And there are some contextual barriers that need to be overcome to make convincing interfaces and interactions. The way you place, move, and transition items should take this into consideration. I have a nice example here that I'll show you. So Passbook has plenty of animations in its interface. There's quite a few principles at play here. But specifically, it does a great job of staging. So I'm not sure if you've encountered this yet. I just kind of stumbled on it. But if you have multiple similar passes, they'll be stacked together closer, like you'll see the 2 red passes and the beige one on the screen. So watch the animation when you choose a pass that's part of that stack. They slide up and fan out horizontally. And 2 of them even move completely off screen. And yet, you immediately know where they exist spatially and how to get to the passes that are off screen because you saw them sliding into position. Another nice touch is that whichever card you have showing in that stack when you collapse it is now the one that will appear on top relative to the others as part of the larger stack. So straight ahead action and pose to pose are techniques that are well rooted in the animation drawing process. So straight ahead action is described as an animator drawing all the frames of an animation individually and sequentially, whereas pose-to-pose is an animator drawing the keyframes, establishing the most important poses of a sequence, and then animating the frames between them. Right, Brenda? Okay, good. Check. So straight-ahead drawing isn't something that's really used outside of very specific instances in our line of work, where you might need a specific complex animation or something drawn on demand to match a finger's movement, etc. But I like a particular phrase in this section about pose-to-pose, where they say, quote, "Each of the positions must be handled carefully for maximum clarity, appeal, and communication. They should be worked over separately and together until they do their job as efficiently as possible. Once these poses relate well to each other, it's a simple matter to time the intervening drawings and break down the action." So instead of just jumping into timing curves and durations and all the other things that make up an animation, you can stop and think about the keyframes or poses that your animated elements are going to have throughout their animation. So if we come back to Passbook and we look at the action of deleting a pass, we see a pretty complex animation with a lot of different moving parts. Once you flip the pass over, there's a delete button in the top left. Tapping it slides up the confirmation prompt, which is styled like a little shredder. Tapping delete then flips both the card and the shredder over, and as immediately as the flip is complete, the shredder begins to move up vertically, and the pass begins to move down, and it comes out the bottom of the shredder is the pass all cut up and transformed into slightly curled strips. There's a whole lot going on here. But if you think about it, there are key poses throughout this animation. So the pass by itself at the top of the screen, and then the prompt in place at the bottom, and then both of them flipped over, and then the pass shredded out the bottom, and then the shredder at the top, and then the shredder going out the bottom. So by planning the keyframes out ahead of time, you can eliminate mistakes that you may have made along the way. So in this example, like not thinking about the fact that the shredder has to move up high up onto the screen so that you can actually see the pass coming out the bottom. Otherwise, you wouldn't see that effect. Follow through and overlapping action. These are two closely related techniques which help to render movement more realistically and give the impression that objects follow the laws of physics. The principle highlights the end of a motion. This is contrary to anticipation, which we saw, which highlights the start of a motion. Now, in character animation, follow-through means that separate parts of a body will continue moving after the character has stopped. Overlapping action is the tendency for parts of the body to move at different rates. Say an arm will move at a different timing as the head, and so on. And to quote from the book again, when a character entering a scene reached the spot for his next action, he often came to a sudden and complete stop. This was stiff and did not look natural, but nobody knew what to do about it. Walt was concerned. And Walt in this instance is Walt Disney. Things don't come to a stop all at once, guys. First there's one part and then another. So a classic example of follow-through in iOS has to be inertial scrolling. It really feels like the content has some weight behind it, because as you scroll and let go, the content follows through and decelerates. And this is carried through all the way to the end, where it continues past the top of the view and avoids the startling jolt of a sudden stop, which would be a harsh contrast to this carefree inertial scrolling. So if you think back to the days of before inertial scrolling, we're so used to it now, but the idea of like scrolling through a list quickly and you got to the end and it just stopped, like hitting a brick wall. Slow in and slow out. This principle pertains to the inertia of objects. You may be more familiar with it as ease in and ease out. So motion is introduced by acceleration, and the final position is predictable by the deceleration of the object. So you get an idea as to where it's going to stop before it even stops. And slow in and slow out makes a movement easier to follow visually. And because more frames are expended over a shorter distance at the beginning, and similarly at the end, than, for example, the linear time movement, which is expressed by the dotted line in this case, it actually appears to move faster, even though they have the same timing. It sounds counterintuitive at first, because when you think slow in, slow out, you think it'll be slower all around. And so this is a very common principle in UI animation. It's a standard timing curve and function, and you'll find it in pretty much every animation tool, and iOS is rife with examples. And we don't have to look any further than the bread and butter page transitions all over iOS. So So not only do the contents of the page ease in and out, the navbar title and controls have their own tweaked timing curves alongside the view. But easing page transitions like this into place is less jarring because we're really swiping out the entire contents of the screen, and then a whole new set of content is moving into view all at the same time. Arcs. So this principle describes that objects tend not to move along straight lines, and most natural actions occur along an arch trajectory. So contrary to, say, mechanical movements, which generally move in straight lines. Arcs highlight the in-between and end of a motion. As an object's speed and momentum increases, arcs tend to flatten out in forward movement and broaden in turns. So think if I wanted to throw a ball across the room. If I wanted to toss it to reach the other side, I'd have to give it a really high arc. But if I threw it as hard as I could, it could go pretty much straight across and would have a lower arc. And an object in motion that moves out of its natural arc for no apparent reason will appear erratic rather than fluid. So be mindful when you're plotting an arc for an object to think through that entire movement. So just looking at the way Maps app exposes controls under the map, you can see the corner of the page actually moves along an arch trajectory up towards the top right corner. Now this gives things a smoother organic feeling than a hard edge. And it's especially nice because the movement ends on screen since we only need to show a handful of buttons. So this way it kind of feels like you're peeling up the corner of a flexible material to peek at something underneath. Secondary action. Secondary actions to the main action give a scene more life and help to support the main action. This principle explains that the motion of real objects have impacts on other objects. And think of how a person swings their arm when they walk, or their arms when they walk. The important thing about secondary actions is that they should emphasize rather than take attention away from the main action. So in the case of really small secondary actions too, say during a dramatic movement, they'll go unnoticed. So in this case, it's better to include them at the beginning or at the end of a movement rather than during. And so, for example, the transition that occurs when a user opens a book in iBooks is an example of secondary action. The primary action is the thumbnail zooming in to fill the screen. The secondary action in this case is the simulated book cover swinging open. Both of these actions occur at the same time, but the secondary action of the book cover opening kind of reinforces that primary action of zooming in on the book cover thumbnail. And this helps complete the illusion. Timing. Timing is a fundamental component of animation. In fact, really the simplest definition of an animation is simply that a value changes over time. On a physical level, timing makes objects appear to obey the law of physics, and for example, an object's weight decides how it will react to a push. And how you would time that movement would affect the perception of that object. So in addition to expressing physical characteristics, timing helps communicate the mood and personality of the object or character. So faster timing can define a sense of urgency, like for alerts, whereas a slower timing is more appropriate for something less critical, like a gesture hint or a progress indicator. And when we're talking about timing, milliseconds are your best friend. The human brain can perceive time down to the single millisecond, and as you experiment and do more animation, you'll realize how much of a difference just a few milliseconds will make. And there are a lot of canned timing functions you can use in animation tools, and we talked about ease in and ease out. But if you venture outside of these pre-made curves, you can precisely control the timing of your animations. But I'll let Mark go into the technical details for you in part 2 of this session. Here's an example of a simple animation that I feel makes good use of timing. Tapping on the camera icon on the lock screen, as opposed to sliding it open with a gesture, bounces the screen up momentarily. It's a great use of animation and timing to communicate with the user, because the screen bounces up enough to expose a bit of the camera UI underneath. Now, letting users get into the camera by simply tapping on this icon isn't desirable, and we can't really throw a prompt up every time because of accidental triggering. So this bounce, as if the screen was nudged, but without enough force to open it completely, tells the user that you're onto something, and it helps communicate that there's a gesture required to accomplish it and what that gesture might be. You'll also notice that there's actually no deformations being applied. It's strictly communicated with timing of vertical movement. Exaggeration. This concept is especially useful when we're talking about small screens, because if a literal imitation of reality could look flat or imperceptible on a mobile display. So a classical definition of exaggeration employed by Disney was to remain true to reality, just presenting it in a wild and more extreme form. Now, it's an interesting concept because it can mean different things in different contexts. So something could feel exaggerated in one instance but not in another. Say if you do something on an iPad versus an iPhone because of the larger screen real estate. An example of exaggeration in iOS is opening and closing applications. If you think about it and you look at it closely, apps open and close from the center of the screen, and they're essentially just a tiny point before rapidly zooming up to fill the entire screen. Solid drawing and appeal. These are two principles that are the most relevant to character animation. So the principle of solid drawing means taking into account forms in three-dimensional space, giving them volume and weight, and just understanding the basics of three-dimensional shapes as an animator, their anatomy, weight, balance, and so on. And this carries into our field to a certain degree when it comes to incorporating a third dimension into our animations. Appeal, for example, like in a cartoon character, is pretty much the equivalent of what we might call charisma in a real actor. So a character who's appealing may not necessarily be sympathetic. Villains or monsters can be appealing. The important thing is that the viewer feels the character is real and interesting. And I think this can be related to UI animations as well, in that compelling and well-thought animations can have appeal to users too. And so I'm just briefly going to touch about some of the tools that you can use to experiment with animation. Keynote, as you've seen, is great for banging out quick and dirty prototypes and examples. I actually restricted myself to Keynote to do all the red ball animations. It's great because there's next to no learning curve. It's a great tool for novice people to experiment with animation. It actually has a lot of great functionality that's kind of just under the layer, the top layer of the app. Hype is a keyframe-based animation app, and you actually record the movements you want, and it'll automatically create the keyframes for you. What's cool about it, too, is that it outputs animations that can be viewed in almost any browser using JavaScript and CSS and HTML. Quartz Composer is a node-based visual programming environment for Quartz by Apple. It's distributed for free as a developer tool. It's kind of hard to find on Apple's site. Apple hasn't really given it a lot of attention in a while, but it works really well, and it has some really fundamentally interesting components to it. And for myself, I really like CSS3 and JavaScript. They're very potent tools, favorite of mine. And if you want a good balance between coding stuff and seeing results quickly, that's your ticket. So in conclusion, whether it's the reassuring and comforting pull to refresh or the simplicity of an indeterminate progress indicator, animation lets us connect and communicate with our users on an emotional level and sometimes drastically simplify our apps. Animation doesn't necessitate complexity. Consider the personality of your app and how you can tastefully apply animation to improve it. Take the time to consider these principles when you're designing your animations, and I actually encourage you to look for other sources of inspiration. And like anything else, animations are good in moderation. Thank you.
Good morning. I'm Mark Pospisil, mobile architect at YMedia Labs. And Phil has told us about design principles for use in animation. And so I'm here in the second part of this talk to go over some of the technical aspects of that. So since I'm a developer, I thought we'd just dive right into some code here and get right to it. No, actually, I'm not going to do that to you. So what I have created is a sample app, and it's up on GitHub, and you guys can download it. And if you're technically inclined, you can go in there and you can look at the code. And there's code in there that demonstrates pretty much everything that I'm going to talk about today, all the principles. And even if you're not technically inclined, you can use the app and you can play with it. And it has settings that let you sort of deconstruct and modify the animation so you can play around with those. So I hope that there's something there for even non-technical people. And so the sample app has 3 animations. There's a red ball animation, of course. There are many red balls, but this one is mine. There's a 3-dimensional fold animation. And there's also a flipbook-style flipping animation. But first, I want to talk about what happens when you animate something in iOS. So you have a ball there, and it's a view, and you're going to say, animate this to the right side of the screen. And the ball moves over there. But how did the system do that? How was that accomplished? Well, the first thing you have to realize is that there is no ball, right? There's just like a series of bits that get translated to pixels that are on the screen, and they're either illuminated or not. But our eye perceives those pixels as a ball. And the second thing you have to realize is that there is no movement. That ball did not move. It was just drawn at different positions over time, and our eye perceives that difference in position as movement. So, well, how in fact did the system know how to draw that and put that at the different places at the right times? Well, of course, it's because we told it what to do, and it figured it out. So you tell it what the start value is. It's on the left side of the screen. And you tell it the end value, which is the right side. And you say how long you want it to take to get there. And you pass it something like a timing curve, which in this case is a slow in, slow out curve. And so now the computer, with this information, knows where to put that ball at any point in time. So after a half second into the animation or whatever, it knows that the ball ought to be there. And so it uses that to position that over time. And I think this kind of comes up later when we're trying to achieve certain effects in animation to understand how the system does things when we sort of tell it to go ahead and do a simple animation for us. So UIkit is the API that Apple has provided to us to create the user interfaces for our apps. And the great thing that I really love about UIkit is that this was a framework that was designed from the ground up to make animations easy to implement. And it's nice. You basically create animations really easily, and you fire them and you forget them. You tell the red ball to animate, and then you don't have to worry about threading issues. Your app can just continue on with what it's doing, and the system takes care of completing that animation for you. And when you're using UIkit, there's this concept of a view. And views are just these little rectangular areas of content on the screen. And if you're not a technical person, the whole screen of your iPhone or iPad is a view, and usually each button on there is a view, and each control is a view, and often each piece of text, each map, each little snippet of web content, that's all a view. And all these things that are views have properties that let us manipulate them and position them and customize their appearance. And it happens that many of these things are animatable so that we can create animations from them. So with a UIView, you can animate the center, which is its position. You can animate the bounds, which is the size of that rectangle. You can animate something called frame, which is just center and bounds together, really. There's alpha, or opacity. That's the transparency of something, so you can fade things in and fade things out. You can animate the background color if you want to, from red to blue to black. And there's something called a transform, which is really very powerful. A transform is a mathematical operation, and this lets you translate or move things or scale them or rotate them. And this gives you really a lot of power to do a lot of great stuff. And you get options you can do when you're using UIkit. So, of course, you can set the duration and a delay if you want, so it doesn't start right away. And you can set timing curves. So you get 4 timing curves in UIkit. You have linear, ease in, ease out, or ease in, ease out. And you can choose between those different timing curves. And each one of those gives a different impression to your user when you pick those. You can tell the animation if you want it to auto-reverse, so if you want it to go back and undo what you did. And, of course, it can repeat over and over again. UIkit even gives you a couple sort of built-in transitions for free. So you can do things like a page curl, or you can flip a card over to see what's on the back of that card. And so these are sort of built-in system things you can access. And there's a couple other minor options as well. So UIkit gives you the ability to do a lot of really great but simple animations. So in our app, it would allow you to do something like moving the red ball. But it also lets you do stuff like having a side pane swipe open, a la Facebook or many other apps. So, right, this is the sample app here, and I can add in scaling and opacity, and then I can run the animation, and it will shrink and fade out as well. And that's all the kind of stuff that you can do using UIkit. However, there's some things that you can't do using UIkit, things that are limitations that you can't move past. So one of them is that you're restricted to those 4 preset timing curves that I mentioned. If you want to go beyond those, you need to switch into a different technology. Another one is that there's no access to animating layer properties. So each view you have is actually backed by something called a layer, which is in core animation. And these layers have great properties that let you customize the appearance of your views. So you can add drop shadows, you can put borders on your views, you can round the corners of them, so you can get these great rounded rects like Steve always liked so much. You're also limited to simple interpolation, right? When you tell the ball to go from the left side to the right side of the screen, it's going to go on a straight line. And you're also limited to 2 dimensions. So if you want to do cover flow or something like that, then you're talking about core animation or maybe OpenGL. So to get more, we have to go into core animation, which is sort of the next level deeper. And core animation is, as you might imagine, a framework especially designed to make animations easier. But core animation is really the system that takes your content and renders it and sends it to the GPU, and then it eventually gets pushed out to the screen. And it's designed to be lightweight, and animations, again, are easy to create. And they're sort of fire and forget. You just launch them, and they go. And then the system handles completing those animations as you told it to. And in UIkit, we had the UIView, and those were our views. In core animation, the concept is called a layer. And so the layer is that rectangular area of content, and the class is CALayer. And CALayer has properties that you can also animate, much like UIkit and UIView. So you can animate position and bounds and opacity. And you can actually see that there's quite a few things that you can animate. So already by going to core animation, you've just increased the number of tools in your toolkit by quite a lot because there's a lot more you can do here. I think there's 4 or 5 properties just on drop shadows for animating different effects of those. And that's just CALayer. CALayer is sort of the base class, the simple layer. But there are other ones as well. And those other classes have animatable properties too. So CAShapeLayer is one of my favorites. That's a layer that its bounds are masked to a path. And what that means is that instead of being a rectangle, your layer can now be a circle, or the shape of a jigsaw puzzle piece, or the outline of Apple's stock price over the last month or so, right? And you can animate those paths and those shapes, which is a really fun thing. There's CAGradientLayer, which paints gradients for you in an efficient manner that's optimized for the GPU, and you can animate the colors and the start and end points and the locations of those colors. There's CATextLayer, which presents text, and you can animate a couple things like font size and font color. And there's even more classes beyond that, but they're worth looking into. Now, when you read about core animation, they talk about 2 kinds, sort of, implicit and explicit animation. Now, implicit animation is really quite simple. And this is the one line of code I'm going to have in my talk. I think maybe you can get through this. And the way you would trigger an implicit animation is just by setting the property. So you would say, you take your red ball, if it was a layer, and you'd say you wanted its position to be the right side of the screen. And it would just animate there, and it would take a quarter of a second to do that, and it would use a default timing curve, but it would animate without you creating an animation. The opposite, of course, is what we're maybe more used to as programmers, is an explicit animation, where you create the animation, and you tell it what you're going to animate and what the values ought to be, and then, of course, it'll do that too. You can do both. And implicit animations, they're really nice for certain things. They're often good if you're doing direct response animation, if you're having something follow your finger, and so it's moving around the screen. It's quite nice to use implicit animations to just have it animate just that little bit from your last finger position to your next one. But there's some things that it won't do. So I'd mentioned that every view in UIkit is backed by a layer in core animation. But those layers can't take advantage of this implicit animation. You have to have layers that are just by themselves. So you can't have a view without a layer, but you can have a layer without a view. And it's all right to mix and match these things. So you can create a view so that you have things like touch interactivity on it. Then you can add a bunch of layers to it, and then those layers can be implicitly animated. And the implicit animations are configurable, so you can set the timing of them. If you don't like the quarter-second default, you can change the timing curve. You can even, for specific layers, set up different animations for different properties. You want to say, okay, I want this to happen when I animate the position, but I want something else to happen when I set the color property. And you can set up your own animations for everything. And I just want to point out that not all of the animatable properties on CALayer do the implicit animation. So the exception is usually paths. Paths are kind of complex. So I'm talking about the shape of a drop shadow or the shape that masks the shape layer. So those things you have to explicitly animate. So what sorts of things can we kind of create using core animation? What we have here, when you're creating an animation, you tell it what to do, right? So you set the property that you want to animate, and then you set the duration, how long it's going to take. And of course, there's an optional delay you can set. And you set the from and the to values, right? Where it's starting at and what it's going to. And you can set a timing curve. And now you have a little bit more tools. Now you have 5 presets. So you have linear, ease in, ease out, ease in, ease out, like you do with UIkit. And you have something called default, which is different from the other 4. And then you can actually make your own where the timing curve follows any cubic Bezier path. And don't get scared about that. We'll talk about just what a cubic Bezier path is and what that means for you. Okay, now here's what I was thinking of. Here's the kind of thing that you can do with core animation. So this is just a folding animation here, 3-dimensional illusion of a piece of paper folding. So this is sort of typical of what you can do in core animation that you couldn't do with UIkit. And so in these basic animations where we tell the red dot, for example, to go from the left side of the screen to the right side of the screen, and it goes there in a straight line, right, because it's using interpolation. But sometimes you want more of that, as Phil talked about. And you can specify a keyframe. You can use what's called keyframe animation, and you can specify that I want this dot to go through that upper position there, and it will do so. And of course, you can have more than one keyframe, and it will move through those different positions. But if you've been kind of watching, you can kind of tell that it's really just using that linear interpolation, but moving between the sequential keyframes. And sometimes you want something that's more smooth than that. The great thing about keyframe animation is that in addition to just passing these individual frames you want, you can also pass a path, and you can tell it to animate along that path. And then you get a nice smooth arc there, which is that arc principle that Phil talked about. And the nice thing about this path is it doesn't have to be an arc, right? It can be any shape that you can define a path for. So it could be the outline of a letter, it could be the shape of a cloud, it could be a racetrack. And now all these animations where we're animating a property on a view or a layer, that's just one little building block. And just like with a Lego building block, the fun really starts when you put these things together and add them up and you make new structures out of them. And it's the same thing with animations. So you can take simple animations, of course, and have a lot of them going on at once, right? So you can do multiple animations happening at the same time. And this can be different properties on one layer. So for example, you can have something move and fade out at the same time. Or you can animate several different layers or views happening at the same time as well. And that can be the same or different properties. And using this, doing these more compound animations can really enhance the illusion that you're creating for your users over just a simple, one-piece animation. And so an example of this is the folding animation, which is in the sample app. And you look at this and you think, okay, it's folding, right? I'm sort of rotating the center panels, and that's a transform, and that happens. But there's actually a couple different things going on there that you might not be paying attention to. Now, if I take the shadows off, now look at this. I can't really tell where the paper is folding anymore. the illusion is sort of lost. It's not very effective like this, even though it's rotating. So you can come in and put the shadows back, and now you can really pay attention. And because those shadows, they work together with that rotating to really create this illusion of this piece of paper folding. You know, you can't have one without the other and have it really, you know, pull off and be effective. Another thing you can do to group your animations is chaining, right? One animation stops and then another one starts. Or maybe actually you have a whole series of animations happening, not just one or two, but a whole sort of cascade system of animations. And I had said that both UIkit and core animation are sort of fire and forget. You like set up your animation and you tell the system to go and it just, you know, does it. But the good thing is that it will tell you when it's done. So there's something called completion blocks that you get both in UIkit and core animation, and it can tell you, hey, I'm done with that animation, and so then you know that you can then start the next one. And these completion blocks can be set up not just when one animation finishes, you can do that for sure, but also when a group of animations completes. So, you know, really, when it gets really effective is if you have a group of animations and you fire that, and then when that's complete, you set off another group of animations. And so an example of this from the sample app is a flipbook-style page flipping. And you might just think of this as being a single animation, but there's actually two animations that happen one after the other. The first, I'm going to be flipping this page forward, and the first animation is this half of the screen rotating up until the page is vertical. And then the second animation is the new page folding down onto the other side. And those run one after the other, and they appear just as one animation, but it's really two animations, 1, 2. And going back 1, 2, like that, just chained together. So I wanted to talk about timing curves. So timing curves are really important. These are what determine how the property that you're animating varies over time during the course of the animation. And as Phil mentioned, that these are really effective, and having different timing curves really presents a different perception to your users. And so there's 5 in core animation that are sort of built in. One is linear, so you have a property that just has a constant velocity over time. And then there's ease in, which starts out slow, but then it accelerates. And there's ease out, which starts out fast, but then it decelerates towards the end and just eases into position. And then there's ease in, ease out, which is like the slow in, slow out Disney principle, where you start out slow, and then you accelerate through the middle, and then you decelerate at the end. And then here's this new one for core animation that's called default. And this is the default one, of course, that you get when you use implicit animations. And it's sort of a gentle ease in. So it starts out a little slow and accelerates a bit, and then maintains a constant velocity throughout the rest of it. But the neat thing with core animation is you don't have to stay with just those. You can make your own timing curves. Like I said, they have to be something called a cubic Bezier path, or a cubic Bezier curve. And I know you might be thinking, but I was bad at math in high school or college, right? But if you take home 1 point from my talk about timing curves, it's that a cubic Bezier curve can be determined by 2 points. Those 2 points define the curve. So to tell the computer that you want a certain curve, you just have to tell it those 2 points. You don't have to have any kind of really complex mathematic to figure out what the point of this, you know, the actual path of the curve is. But you're thinking, well, I don't know what, you know, positions of these points are going to make what curves. How do you figure that out? Well, I made something in the app that looks just like this. And it has these little green dots, which are the 2 control points, and you just take your finger and you put them on the dots and you drag them around, and it'll make a new curve for you. And it'll tell you what the value of those points are. So if you're a developer and you find something that you like, and you run the animation, of course, and it will perform the animation with the curve you just gave it. But if you like one of those things, you have the numbers right there that you can put into your app and use that timing curve. And if you're not a developer, you can still see those numbers that you made, and you can tell that to your developer, and they can put it into the app, and they can use that timing curve that you just made. So this is what it looks like in the sample app. We have the red ball, and we're going to animate it across the screen. But what we're going to do is we're going to play around, and we're actually going to set up the principles of anticipation and follow-through using a timing curve on this. So you swipe open the settings, and you pick timing curve. And you can say, well, I told you there was 2 control points, but you just see the number 2 there. That's just because they're on top of each other. All you got to do is start dragging here. And you can make yourself an ease-in curve, or a linear curve, or an ease-out curve, or ease-in, ease-out, or you can do something different. Okay, and now this is going to set up both the anticipation and the follow-through, because if you look out right here where it's dipping in the wrong direction, that's the anticipation, because it's going to move in the opposite direction at the beginning. Then it's going to accelerate quickly, and then it's going to overshoot before snapping back into the final position, and that's the follow-through. And so you can just run this. You slide shut the settings there and tap on the ball to run the animation. Anticipation, follow-through. Anticipation, follow-through. And you set that up on that animation without having to tell that specifically, oh, yeah, I want you to go back that far and then go over past here and then end up in your final position. You don't have to tell it the 3 different points. You just tell it the start and the end and that timing curve, and then you get this set up for you. So Apple has given us some tools that allow us to create really powerful user interfaces and user experiences for our users. And both UIkit and Core Animation give you a lot of power that let you create some really complex animations with a modicum of effort, at least compared to how difficult these things were to do historically and with other frameworks and other platforms. And I can't believe that Phil caught my line for this, but we'd sort of come up with this independently. But as Uncle Ben said to Peter Parker, with great power comes great responsibility. And just because you can do an animation doesn't necessarily mean that you should, right? So every time that you're thinking about putting an animation in your app, I would encourage you to think of why you're putting it in there. Because good animations provide some sort of context for your users. They help make some transition or some action that they performed be less jarring so they can figure out what just happened within your app. And the goal of an animation, should be to really enhance the user experience, to make that a better, experience for them using your application. And because of that, because I think it's so important to think carefully about, what you're animating and quite how, and what the best way of doing that is, I personally think that design considerations are much harder than the technical implementations. Once you figure out what you should be doing, what the best way of doing that, what timing curve or what thing that you're animating, I think just actually doing it is just a technical detail. And I would challenge you, as app makers, to not just use the system defaults. It's really easy, right? They make it so easy for you. You can just say UIView, animate with duration, bam, right? I'm just going to use the system setup, ease in, ease out, it's fine. But I challenge you to sort of go beyond that and to experiment and to try some different timing curves and see how that can maybe, improve the experience for your users and make it a better app. The code's up on GitHub at this address. You don't have to worry too much about copying it. My Twitter handle is in the conference app, and I've tweeted this already, so you'll be able to find this out there through Twitter or through other resources. Of course, our moderator, Bill Dudney, wrote the book on Core Animation, which is a great resource. There were a couple of talks at WWDC this year on animation, and then there seem to be a couple every year. These are great resources to look to. And of course, just Apple's own developer docs go into quite a lot of detail about this as well. And with that, I will, can't wait to see what you guys create. And thank you.
Fantastic. Thanks, guys, for a great talk. So remember, if you have a question, please post it on Twitter, #RenIO. And I have a couple of questions for you, specifically about this with great power comes great responsibility, right? We're all Spider-Man because we're building apps, I guess. And how do you tell? Like, it's so easy to go off the deep end and build crazy animations that do crazy stuff. How do you like make that that marker where you say this is just too gaudy? We just can't do this. How do you decide that? Is it just a judgment call, or call your designer friend, or how do you do that? What do you do?
Maybe I'll take a stab at this one to start. I think, in my opinion, when I'm working on an animation, I try and think about what this animation is trying to communicate or accomplish. And if we look through some of the principles that we both talked about, there's reasoning behind some of these things. I mean, UIkit has a bunch of ease in and out all over the place, and I think that may lull some people into a sense that that's just something you should use all the time. But I think you really need to think about what it is that you're communicating, and also don't waste your user's time. Like the timing and the duration of animation shouldn't take away from the person being able to actually use the app.
I would just say, well, as a developer, of course, I have no taste. So, I rely heavily on my designers to tell me what's right. But one principle I would say is just always stepping back and maybe giving your app, your prototype, to someone else who's not in the industry, a child or a spouse or a partner, and having them play with it. And I think they can really give you valuable feedback on whether your cool animation is really serving its purpose or not.
So one other question I had that's related to that topic is it worthwhile to sort of push animations over the top when people first start using the app, maybe as a discoverability thing, where on the anticipation thing, when the finger goes down and it looks like it might be a swipe, programmatically it looks like it might be a swipe, is it okay to sort of go over the top at the beginning when the user's first using the app, but then know that after time that's wasting their time and you don't want to go down that path? Is that a worthwhile thing?
I don't necessarily think that that's a worthwhile thing. In my opinion, if your animations feel like they're going over the top to start, then they're going over the top, period. In my opinion, there's a balance that can be found between being able to communicate things like for example, the slide to unlock on the iPhone. There's that kind of continual linear glow going across the text. And to me, that's an example of an animation that's kind of reinforcing a gesture, but it's not annoying or over the top to have it going all the time. So I think that the idea is that you don't necessarily need to have one or the other. And when we talk about, again, some of these principles, it's not a matter of making the most complex animation you can think of and then reducing it later on. I think that there's a happy medium to be found throughout an application.
Thanks.
Yeah, I'm pretty spot on with that. I mean, this actually illustrates another sort of problem with developing apps, which is that, how discoverable are your gestures, right? And how complex is your app, right? Like a lot of people state that the goal of an app should be that you launch it and the thing is just so obvious that people don't need any kind of introduction or help. It's just clear from the start where everything is, which is a very interesting goal, but depending on what you're trying to achieve with your app, it's just not always possible, right? Sometimes you want to have a more gesture-driven application so that you can have the content be the forefront and not have all these buttons all over the place, right? So that they can use it. But then how are these gestures discovered? And so people have different techniques, right? Such as having the tutorial that runs at the start of your app. But I think as an alternative to that, having something like that little bounce on the lock screen, which if they make a sort of a misstep, that then shows them a clue as to what the correct step might be. I think that has its uses. If you're creating an app that is so complex that it's not immediately obvious how to drive it.
Excellent. All right, last question from the audience from Twitter. Are there any libraries on GitHub or wherever where there's some great animation built into those libraries to help users with gestures, with animations and gestures or whatever? Are there any particular libraries that you found, or do you usually write it from scratch? Or everybody should download your sample code, by the way. But apart from that, is there other stuff on there that you use?
Not that I found that I'm aware of. I actually have a couple other libs up on GitHub, and one is something that does like really easy fold and flip transitions. not necessarily small animations, but if you just want like the whole screen to go, to another screen or something like that, I've got something that's pretty plug and play. It's not perfect. There are, issues with it when you get down to the technical level, as there almost always are. But mostly I tend to write things myself, and I find that, an animation is actually, if you're doing just like you want the page to turn, that's easy. What's really hard is if you want the page to pan to your finger, right? Because then that's a lot more complex. You got to follow the finger, and then when they let go, you got to decide what they really meant, right? Was the finger moving a little bit when they let go? Because then you probably want to complete the flip in the direction that their finger was going, but if it was moving but not enough, then maybe you just have it fall back. That, to me, is like 10 times more complex than just having like a canned transition, and I haven't found libs that, really encapsulate all that for you.
Fantastic.
I'm just going to add to that. It's not a direct response to the question, but it's just kind of I want to encourage people that aren't programmers, like designers, or pretty much anyone else involved in app design, period, to don't be afraid to venture into Objective-C and animation. I mean, there's a lot of great books about core animation out there, and Objective-C, it's not as hard as it might seem at first, so don't shy away from maybe experimenting a little bit and getting your feet wet in it. It's actually pretty neat stuff.
All right, fantastic. Thanks again, guys.
Great.
And now here's Tim.
All right, thank you.